Hi guys, it's Wednesday, March 31st. This is our math lesson for today. So as always, I'm going to start off with our simple solutions and then I'll move on to our Eureka math lesson. So starting off, I'm on lesson 95 in simple solutions. We're going to take a look at which questions Mrs. Pierce deemed that she thought were the hardest 6 questions on the page. I circled those questions and then I will go over the questions on the opposite page. So I circled 1, 4, 6, 10, 11, 13. Okay, so I'm going to go ahead and flip it over and solve all of those questions. And then if you have any questions about this, go ahead and email me if there's anything that we could not figure out. So number 1 says decompose the fraction 5/12. Rename it 2 different ways. So all that means is I need to set up 2 addition problems that equal 5/12. So what are 2 different ways that I can add to find 5/12? Notice I put the denominators all the same as 12 because when we're adding fractions, the denominator stays the same. So I know one way to make 5 is 1 plus 4. So really that's 1/12 plus 4/12 equals 5/12. Then I could also do 3/12 plus 2/12 equals 5/12. You could come up with any other way. You could add all unit fractions. You could say 1/12 plus 1/12 plus 1/12 plus 1/12 plus 1/12 equals 5/12. You could also do 1/12 plus 2/12 plus 2/12 equals 5/12. There are a multitude of different ways to solve and find our answer. I circled number 4 because rounding has caused us a little bit of issues. So I want us to look at rounding 25,679 to the nearest 10,000. I want to think, well, which one is my 10,000s place? It's the number 2. And so the number in our thousands place is going to help determine if we round up or down. And remember, I love seeing this on your paper when I do. It's your vertical number line. I think that's one of the biggest helpers for this. I'm going to put 25,000. Oh, 10, the biggest 10,000. So not 25,000. I'm going to put 20,000 and 30,000. Those are the 2 10,000s that this one sits between. Our halfway point is 25,000. And I can see that my number, 25,679, sits in between my midway and my top endpoint. So since it's between these 2 numbers, I know that my number rounds to 30,000. Let's see here. Line G, J, actually ray GJ and ray GK are perpendicular. What is the value of E? When it says that these 2 lines, I'm going to highlight them. When these 2 lines are perpendicular, that's the same as saying that that's a right angle. We know a right angle is equal to 90 degrees. So we need to add together 18 plus 53. Those are those 2 numbers. 8 plus 3 is 11. 1 plus 1 plus 5 is 7. So I'm going to be subtracting from 90, 71. 0 minus 1, I can't do it. I have to turn 9 to 8, and I have to take one of those 10s and put it into 10 ones. 10 minus 1 is 9. 8 minus 7 is 1. E equals 19 degrees. Number 10, What is the difference in height between the tallest sapling and the shortest sapling? So our tallest sapling sample is 5.5. Our shortest is 3. So we need to do 3. We have 5.5. I'm in box 10. I was trying to find the correct box. 5.5 minus 3 equals. Okay, so to make this easier for me to read, I'm going to keep it as 5.5, but I'm going to split 3 apart. So that I'm going to take one of those wholes and make it into 2 halves. And that leaves, basically 2 halves is the same as 1. I'm sorry, I'm confusing everything. I am keeping this as the same. It's 3 halves. I was getting that confused. This will be 0 halves equals. That's what I wanted to write. Blah, blah, blah. Going back a little bit. I'm sorry, guys. I just confused us. We have 5.5 minus 3 and 0 halves. That will help us solve. 1 minus 0 is 1, so we have 1 half. 5 minus 3 is 2. So our answer is 2.5. I'm sorry I confused us on that one. We have next a matrix model. So we're going to do 61 and 36. 60 times 30, well, 6 times 3 is 18. That means 1,800 or 1,800. 30 times 1 is 30. 60 times 6, 360. And 6 times 1, 6. So I'm going to add across. I have 1,830. Then I have 360 plus 6, 366. 0 plus 6 is 6. 3 plus 6, 9. 8 plus 3, 11. And 1 plus 1 is 2. 2,196 is our answer. Finally, I'm going down to box 13. The watch repairman needs to replace the battery on some watches. He has 43 minutes before closing. How many batteries can he replace if his replacement time takes 8 minutes, and how many minutes will be left over? So I'm thinking 43 divided by 8 equals. Well, I know a multiplication problem that involves 8 that gets pretty close to 43 without going over. If I do 8 times 1, I have 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. Can I add one? Can I multiply one more time? If I did 8 times 6, I have 48. That is too many. So I need to stick with 5 as the amount of times. And then if I do 8 times 5, I get 40. So 8 times 5 giving us 40. We have 43 minutes. She will have, or I guess he will have 3 remaining minutes. Okay? So he can repair 5 batteries on the watches, and we'll have 3 minutes remaining. Okay? Those are the ones that I solved today. We're going to go ahead and I'd like you to just follow along on a piece of paper while I solve some questions, and then we'll talk about our problem set. Okay, so like I said, guys, if you would, we're going to follow along with what I'm writing. If you write this down on a piece of paper and bring that paper in tomorrow with your lesson, I will give you 2 Firebird bucks. So if you write everything I write down on a piece of paper, it could be a blank notebook page, it could be a computer page. If you bring in that paper with what I write down, I will give you 2 Firebird bucks. So first, let's take a look. We're going to draw an area model that will show 3/4 equals 6/8. Okay, so we're going to prove that with an area model. So first, like we did yesterday, we're going to draw our rectangle. We're going to split this rectangle into fourths. And because we're doing fourths, we need to look at how many we're shading. Well, we're shading 3 of those fourths. Okay, and now I would like us to see, well, how can I show eighths? I need to split my area model into halves. So now that I've drawn a line halfway through, I have 3/4 represented on top, and I have 6/8 represented on the bottom. Well, let's use some unit fractions to show addition so that we can have, show that 3/4 is equal to 6/8. 3/4 equals, well, we need to add our eighths together. 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8, and that equals 6/8. We can also say that if I wanted to, I could split up this so it looks like that. When I put those parentheses around each one, really I've made this into 2/8 plus 2/8 plus 2/8. What multiplication problem is that? If you said 2/8 times 3 equals 6/8, you would be correct. You could also go back to your unit fractions and say 1/8 times, I got to think how many times did we add it? 1, 2, 3, 4, 5, 6 times 6 equals 6/8. And all 1, 2, 3, 4 problems are all equal to 3/4, which is the same as 6/8. All of those are equal to one another. All right, let's try another one. So if at any point you need to pause the video so you can see what I wrote down, do so, and then I am going to continue on to number 2. So I'm doing a second question. We're going to prove that 2/3 is equal to 8/12. So I need to start off with my area model. I have it split into 3 equal parts, and I shade in 2 of those 3 parts. Now, I need to label that this is 2/3. I am going to decompose my larger area model so that we can show 8/12. So I am going to split this 1, 2, 3, 4. Notice if I think 3 times something will give me 12, well, 3 times 4, I need 4 rows, will give me 12. So I have 8/12. I can express this so that I can show 2/3 is equal to, well, that's 1/3 plus 1/3, which is also the same thing as, sorry, you couldn't see my writing, 1/12 plus 1/12 plus 1/12 plus 1/12 plus, I'm putting some parentheses, you'll see in a moment why, 1/12 plus 1/12 plus 1/12 plus 1/12. That is the same thing as 8/12, which I ran out of room. 8/12. I can write that as a multiplication sentence. 2/3 equals, well, 8 times 1/12. I can also say is equal to 8/12, which I can also write as 2/3 is equal to 4 times 1/12 plus 4 times 1/12 equals 8/12. Okie doke. We're going to do one more question together on a piece of paper. I need to get a new page. Again, remember, if you write down everything that I wrote down, I'm going to give you 2 Firebird bucks. So we're going to draw an area model, and you're going to follow some directions on that area model. This area model is going to show that, hey, this whole thing is equal to 1. First, I'm going to show that it's equal to 1/3. So I'm going to shade this one in. 1/3. If I wanted to say that it's equal to 2/6, what would I do? Yes, I would divide it in 2. 2/6. Well, what if I had 3/4? I'm going to draw another one. What if I had 3/4? I'm going to draw 3/4. Is equal to 9/12. If I want that to show 9/12, I'm going to have to split it 1, 2, 3 more rows. 9/12. Okay? Alrighty, so these are the 2 area models that I'd like you have to draw. And then you had this problem and this problem. So if you have these items on your page and you turn it in with your work tomorrow, I will give you 2 Firebird bucks. All right, we're going to go over what the problem set is, and then that is your work for today. Okay, so for your problem set, Olive and Charlotte, yours are in your book. Everybody else, yours is in your red folder. We are only going to be doing questions 1A and B. and then all of 3. I underlined for my in-person students, Olive and Charlotte. Since you're at home, I'd like you to underline the following items. It says each rectangle represents 1. Draw horizontal lines to decompose each rectangle into the fractional units as indicated. Use the model to give the shaded area as a sum and a product of unit fractions. Use parentheses to show the relationship between the number sentences. The first one has been partially done for you. So you need to follow along. Originally it's 2/3. Now I see 1, 2, 3, 4, 5, 6 parts. So I'm going to fill in 6, and there's 4 shaded. So you need to fill in the missing information for these problems. Go back in my video, I did this on the separate pieces of paper. So you're going to finish A and do B. And then, see, it says tenths. Right now it should be fifth. It's in fifths. You have to show tenths. On this one, you're drawing an area model for a fraction with units of thirds, fourths, or fifths. You're going to shade in more than 1 fractional unit. So that means more than 1/3, more than 1/4, more than 1/5. It has to be more than the unit fraction. And then you have to partition the area model again to find an equivalent fraction. And you're going to write the equivalent fractions as a number sentence. Okay? And it says if you've written a number sentence like this one already on this problem set, start over. So they don't want you to copy one from other places on this page. You are only going to do, you're going to do your own, one that has not been said on this lesson yet. Let me know if you have any question, guys.